Okay, I'm going to do friend search project overview. So this is a mini social networking platform built for data structures and algorithms group project. It implements theme A5, friend search, and autocomplete, demonstrating six additional required data structures, whereby the system is split into a Flask REST API backend and a React TypeScript front end. So so the theme is F5 friend search, which is autocomplete using an index map. Backend used was Python 3.12 or SQLite by Bcrypt and PyJWT. Frontend we used React 18, TypeScript, Vite, CSS modules. So uh, five-step process. Step one, use cases, whereby a user can register an account and log in with the password. Just how I'm showing you right now. As you can see, you put your email, username, which you can use when you display the name. Now you can create your own password of minimum of 6 characters or 6 to 8 characters. Bio, just put something which you like to do, like I love coding, then create account. Then as you can see, you are brought to the home page where you can see your profile, showing your name, all that, like that. So next, a user can search for friends by name or username. For me, so you are searching Alice and it comes automatically, so you can add as a friend. And you can see the friend request is sent. So when I go and log in as Alice, putting the password there, then you sign in. Now I go to the request. You can see the request has already arrived from the Collins. So what I do is I accept, and the friend request accepted. So when I go back to Collins profile, I can see that the request, you can see there is no pending friend request, so it's accepted. And I can see from my friend list, Alice is one of them. Yeah. So I can now go next, and I can see my recent searches. Alice comes on top. Okay. Yeah. So next, a user can view search history and can do the last search. As you can see, recent searches here you can view from top. Okay. Next, user can send, accepts or rejects friend requests, what you've just seen. User can you can view mutual friends and friend suggestions, which you've already done. Okay, you can see there's one mutual. You can see there are many mutual friends who I have ranked. Okay. Next is you can also, a user can view any profile. Such, for example, when I click on Dave, I can see his profile, his mutual friends, his values, some of his friends are Henry, yeah. Next, I can do, now, this is important, friends can also message each other. So what I do, I can go start a conversation. And can say I've sent a message, so when I go to the next, to the Alice, I can see Collins. Okay, you see, then when I reply, I go back, you can see it's already, when I reload, it's already here. Well, that's how it works. Okay, to the source code, VS Code, this is VS Code. So the backend used was Python 3.12, Flask 3.0, and SQLite via built-in SQLite 3. So there's Bcrypt and PyJWT. So in the data structures, you can see there's tree.py, where the tree is the core feature of the theme 5, where now it stores both usernames and displays names mapped to user IDs. On search, it traverses the prefix path in OM, then collects all user IDs under that node via the DFS in OK. As you can see there. Yeah, that's how we use try. Basically, to store both usernames and display the names. So next we could go, there was friend graph, where we used graph.py. So what it does, it's just an adjacency list using Python dictionaries. So what it did was to represent friendships, which also aided in finding mutual friends and degree 2 connections for the people you may know of each. So that's where this comes about. Graph.py, data structure. Next was the search history, where you saw from our example, we used stack.py. So what it does, it's just the part where autocomplete query was done. This is what it was responsible for search. So what it does, it's just that it a per user last in first out stack capped at 20 entries. So each autocomplete query is pushed, whereby now the undo endpoint pops the top end. Yeah, that was what the data structure was able to do. Next was queue.py. So what this did was it was responsible for tracking unread counts per receiver in a hash map or O1 lookup, whereby what it does is just using SQLite is just the full message history, where now the queue is an in-memory cache. Yeah. So messages, all the messages you saw in the example, queue.py was responsible. Next was the search result, whereby it was come from heap.py. Heap.py, yeah, it is. So what it did was just for each autocomplete result, the mutual friend count is used as the score. Remember the part where we did mutual friends, where it was ranked? This was where it was, this is the reason why. Using heap.py, which is a heap data structure that was responsible for search. Okay, next there was merge sort and binary search. So this was responsible in sorting.py. So what it did is just that it was the custom implementing of merge sort and binary search. So what it was used is just to sort autocomplete suggestions alphabetically and to search sorted username lists. Yeah.
Okay, so for the remaining parts, we have the db.py, where we initialized our SQL database using SQLite 3. This is our database. We named it the friendsites.db. For the next part, we have the house page, which main part was constructing the JWT token sent to the front end. Mostly dealt with the sessions. Next, we have the init.py. This is how we created our app and added the demo data. And next, we have the sort. Now this is where we brought together every part of the data structures, connected them to work together. Next, we have the routes. This is each routes, the out route for the registering and the logins, the chat routes for sending and receiving chat messages, the friends route for sending requests, accepting, rejecting, pendings, and getting mutual friends and suggestions. And this is the search routes, dealt with the autocomplete, history. That's it. Yeah. So the remaining part is the front end. So for the front end, we used React, TypeScript. So this is where we handled the API calls and token handling. This is how we dealt. For the components, we had the charts dealing with everything concerning the conversation, message, and the message threads. The friends dealing with requests, the layout of the page, including the sidebar and the top bar. The search for the history panel. the UI. So for the hooks, we had used debounce. With this dealt with delaying search queries. The use pooling was for firing callbacks in case of an issue. Next, we had the pages. We used state-based routing, since it was a simple project. And then we had our CSS pages. And then for the types is where we defined every TypeScript interface and exported them to the rest of the files. Yeah, and that's it.